There are several equipments, medical equipment in the industry, and these equipments are categorized as critical and non-critical. So the critical equipment, at what frequency we should test the equipment, and that non-critical, what should be the frequency of testing. Usually these are available in the service manual. In the absence of the service manual, there are certain risk scoring is involved through which we can establish the frequency of testing a medical device. The first and foremost is, how safe are we in the industry, in the medical industry? There is a small video and there is no audio in that. The video is going to throw light on various accidents happening in the ICU and the OT theater. Any accidents happening inside the OT theater and the ICU generally does not come out of that room at all. Okay, people outside will not know what is happening inside. Many accidents takes place. Since I am the service engineer, I have seen how many accidents have taken place inside the ICU and the OT. Everything is swept under the carpet. And when they come out and they say a different story to the relatives, very sad it is. Medical errors and negligence happening inside. And we are not going to pinpoint who's at fault. We are going to see how this can be avoided. There are paper clips assessment on accidents taken place in the ICU and the OT. These are all the tip of an iceberg. And we are going to see how this can be avoided. Instead of who was responsible, how this can be rectified. And we are going to see what is an accuracy and precision which is related to the medical equipment. Accuracy in measurement, that's the diagnostic equipment. Precision in delivery, that is a therapeutic equipment. Then we are going to see risk assessment and risk management. What is the risk assessment? What is the risk involved if a medical equipment fails? Nothing happens, something happens, patient crippled for life, or immediate death. If those are all the risk available, how it can be managed with a management program. Importance of testing and calibration. Next, what should be the frequency of testing a medical equipment based on risk scoring. Risk scoring falls under risk assessment. Then we are going to see disposable of medical equipment, how a medical equipment, what is the life of a medical equipment, and how it should be disposed of once the life is utilized. Role of a biomedical engineer in the medical industry. To see the teaching institute to develop the medical equipment department. Student development. So these are all the agenda for today. I do not know how long it will take. And am I audible? My internet connection has gone, it says.
Yes, sir, you're audible.
Okay, fine. Thank you, ma'am. In case if I am, if the internet is low, please call me on my mobile.
Sure, sir.
Thank you. That's a small video. This video is not recent. It's maybe 2-3 years old, but I would like to share it. Please go through the video. Sorry. So that's about a small video. This has happened in US where the rules are very strong. There is called FDA. They are very strict. They have shut down many companies who are not following the norms. And this is happening. Mostly, we are going to see how this is happening because of equipment, and what is the biomedical engineering contribution to reduce it. The biomedical engineers, by doing a good job, they can save so many lives. That's what we are going to see in this video. The accidents are happening, you see, in a commercial air flight is around 0.2%, but the whole world knows because it is happening in the sky. 66% is the death inside the hospital due to medical error. So this is going unnoticed because it is happening in closed four walls. So we are going to see the accidents, road accidents are around 24%, and the rest we are not carrying much about it except the death happening due to medical error. In Indian scenario, we do not have any clear statistics. Whatever we get, the paper clips, it is saying, wow, accusing somebody or whatever it is saying, and this is a tip of an iceberg. Okay, India, we do not have any standards, first of all. So basic safety standards and protocol not followed. The death is because of that. Inadequate knowledge in using the medical equipment. People do not know the total application of an equipment. Lack of knowledge and skill in servicing the medical equipment that is coming under the biomedical engineering. Inadequate training in application to the doctors, to the service providers, to the service engineers, and how to maintain an equipment, what should be the frequency of maintenance. Periodic preventive maintenance program, they are not executed in time. This is the major concern in all our hospitals in India. We always wait for an equipment to fail. When the machine fails, we call the service engineer. And when the equipment fails, you see it fails on a patient. And 2-3 equipments fail at the same time, there is a disaster. So we do not do preventive maintenance. We all have two-wheelers, we all have four-wheelers, and every equipment, every two-wheelers or four-wheelers, they have a periodic maintenance to change the oil, to change the oil filters, and so clean the other filters, and so many things are there. Similarly, for the medical equipment, every equipment has got a preventive maintenance program. Those are not judiciously carried out. And this is the main reason why the equipment fails. And death due to the failure of the equipment will be more. And this is what we are going to see in the paper clips. Checking the performance of the medical equipment is not done as per MDQA protocol. MDQA is Medical Device Quality Assurance Protocol, which is otherwise is part of the testing and calibration. And we have a separate presentation for this. This is a general OT. You see there are so many medical equipments are there. There is a cautery, which gives some power, electricity, current, everything going through the patient. Infusion pump is a critical drug infusion, has to deliver the drug, critical drug in a precise manner. Anesthesia gas machines have to deliver the oxygen percentage in a correct proportion. Otherwise, if the saturation goes less than 60, the patient will slip into coma and he will not recognize. Monitors are second category equipment. Whether they work or not, patient is not going to be affected. But the performance of anesthesia gas machines and the infusion pumps, if the performance fails, the outcome of the patient will be a disaster. So clinicians and OT technicians, they know its application. Doctors do not know the principles of operation of the equipment, but they know the applications. These equipments are to be checked for its quality performance judiciously at regular intervals, which is called the OVP, Operation Verification Procedure. This is available in all manuals, especially in the user manual. These machines are to be tested. Doctors, the clinicians, the surgeons, take it for granted that these machines are working perfect. And if they are not working, it's a different scenario. If they are partially working, it is a dangerous scenario. And that's your cardiac OT. You have an hyperthermia unit, and you have a heart-lung machine. And when you have a HLM and a hyperthermia unit, you know it is a cardiac OT. All equipments have equal importance, but the critical function of each equipment will vary from equipment to equipment. Like a patient monitor, it is only a diagnostic equipment. Heart-lung machine is a therapeutic equipment. That's the function of heart and lung. So these machines have to be checked. Heart-lung machine, you have to check the flow of blood. And the hyperthermia unit, it is a cooling and heating unit. It should be checked for the temperature. Infusion pump, there are a series of infusion pumps used on a particular patient. You see, critical drugs are supposed to be delivered at high frequency by these infusion pumps, critical drugs. If they are set 10 ml per hour, only 10 ml per hour should go, not more, not less. If the delivery is 5 ml per hour, the patient outcome will be ineffective. Not only that, the doctors will think the patient is not responding to the therapy. So that's a very dangerous situation. Partially working equipment is more dangerous than fully disabled equipment. Any high drug delivery will be dangerous to the patient. On the other hand, you keep 10 ml per hour. If 20 ml goes, anything can happen to the patient. Therefore, high accuracy and high precisions are very important for drug delivery. Sorry, I'll just switch off my. Okay. These equipments have to be checked for its performance at least once in 6 months as per MDQA program. MDQA, as I told you, is a medical device quality management program. This is an air ambulance. The equipment, the patients are shifted from one place to another in an air ambulance, which flies under a high altitude, and the weather difference will also be different. So these equipments have to be certified by airworthiness, DA160F, I think. The pilot officer talking to the ground, the radio frequency should not affect the performance of the machine. A baby incubator, a radiant warmer, a phototherapy lamp, and the ventilator. Madam, can you tell me how I can disconnect my video? Is my video visible?
Yes, sir, but it's a presentation. It's not a video. It's a presentation when you do.
No. Am I seen there in the main screen?
Yeah, sir. You're also visible, and the presentation is also on the screen.
Okay. I don't want to. I want to cut my video. How can I do that?
Simply you close the video, sir. Close the presentation. That's it.
Okay.
Yes, sir.
What happened now?
Now there is a blank screen.
Okay. Okay, let it be there. I don't want to disturb it now. It is okay. The ventilator is used for respiratory failure. Phototherapy lamps are used for babies with jaundice. Baby incubator, it creates a mother's womb environment with humidity, temperature, and oxygen percentage. Radiant warmer. See, all these machines, these equipments have got equal importance, but the critical functions are different. A radiant warmer malfunctioning, there are babies burnt to death. BC Roy Hospital in Calcutta, 16 babies died in a day. And some years before in All India Institute of Medical Science, New Delhi, some babies are died under the radiant warmer. Phototherapy lamps are less critical equipment, not touching the patient. Phototherapy lamps are not touching the patient. Radiant warmers are not touching the patient, but the radiant warmer functions are critical compared to the phototherapy lamp. Phototherapy lamp is not working, nothing is going to happen to the baby. Ventilator is a life support equipment. What is a life support equipment? Any equipment that's the function of a human organ is a life support equipment. So ventilator is a life support. Baby incubator, it's a very important equipment. So all these machines are critical and need to work with high accuracy and precision. Every equipment need to be checked for its performance at regular intervals according to the manufacturer's advice. You see over here, ambulances have to be well equipped with important gadgets. You see over here an head immobilizer and a spine board. Usually the damage is more during transport of a patient from the accident site to the hospital. If the damage is 25%, if there are no gadgets like head immobilizer, spine board, and splints, if there is a neck injury without a head immobilizer, the patient before reaching the hospital may die. So you have to have important gadgets. Head immobilizer is to prevent further damage to the neck during transport. Spine board, any spine injury, you have to have a spine board. Splints to protect the fractured limbs. The damage to the patient during transport is minimized with relevant gadgets. So an ambulance is supposed to be well equipped, and these should work in a good working condition. I gave an example like 25% injury at site may become 75% while reaching the hospital if these gadgets are not there and not utilized properly. Look at this. This is an ambulance inside. You have got everything, almost everything in an ICU. You got a defibrillator, you got a monitor, suction apparatus, syringe pumps, collapsible stretcher, consumer. These equipments are exposed to various road. These equipments have to have a certification of shocks and vibrations because they are not a ICU equipment. They may not have great functions, but they are sturdy in operation. So they are exposed to various atmospheric conditions like rain and shine. So it should have a splash test certification. Hence should be sturdy in construction and withstand various temperature and atmospheric conditions. So this is an ambulance inside. The equipment inside the ambulance are slightly than the ICU equipment. So does the testing matter? Equipments are purchased in huge quantities. Doctors' dependency on the equipment is increasing day by day. These days, the doctors don't even touch you due to COVID. Even otherwise, they don't touch you. The clinical acumen, like checking the pulse and telling the heart murmur, those are clinical acumen has gone long time before. It is not there now. You go to a doctor, you say that you are not well. He won't even touch you. He will take a piece of paper, he will listen to you, write some 10 tests, and they'll ask you, go to this lab, carry out the test. Now, the doctor's diagnosis is going to depend upon the equipment where you are going to be tested for your parameters. If these equipments are not working properly, they have to give a wrong reading will going to result in a wrong diagnosis. Diagnosis is going to result in wrong treatment, and you know what is the outcome. The patient have to suffer for everything. So equipment need to be performed for its accuracy and precision, which is very important. Performance of these medical equipment plays a major role in quality management and patient safety, as I said. Accuracy and quality standards are crucial for better patient outcome. So this is very important. Quality management schedule and preventive maintenance program will greatly reduce equipment failure. Preventive maintenance program is very important. With preventive maintenance program, you can always catch an equipment before its failure. Otherwise, it is going to fail on a patient. And when you do a quality maintenance program, the equipment failure rate reduces. Hence, testing and calibration has been mandatory by NABH, National Accreditation Board for Hospitals. Every year they come for auditing. They see that each and every equipment are tested and calibrated with a certificate. Quality management also reduces accident due to equipment failure. This is the major. In an ICU, ventilator failure results in immediate death of a patient. In an OT theater, anesthesia gas machine failure leaves the patient into coma and they die later. So this is quality management is very important for critical medical equipment. Regular testing not only ensures the quality of the product, assuring the patient, it also increases the morale of the attending clinicians. The ICU sisters, the ICU doctors, they get more confidence when the machines are tested and calibrated. They depend on the machine and their morale increases. Proper training to the biomedical engineering also plays a major role in the medical device quality management program. The students coming out of the college, biomedical engineering college, you ask them anything about the theory, they tell you everything on page 64, what is there in the first para. You show them 5 different equipment in front of them and ask them to identify which is a patient monitor. It is very sad to say the fresh biomedical engineers is not able to identify a medical equipment. You ask them to talk about patient monitors, they do in plenty. So training is important. Trained manpower is important. That's an icebreaker. The surgeon is asking to the patient. Okay, so we'll get into the medical errors and negligence. The definition of error is a mistake, fault, blunder, slip up, inaccuracy, miscalculation by both the doctors as well as the biomedical engineers, technicians, nursing staff, whoever it is. So classification or errors are measurement error. There is a huge difference between the measured value and the value of the patient. Maybe because the equipment is defective, the probes and sensors are partially working. If they are not working, it's good. Partially working is very dangerous. Uncalibrated medical equipment, which has got errors, being used on a patient. Human error, measuring technique is a human error. Placing the sensor in the wrong place, using a wrong probe, site of placing the probe are not correct. And this is reading a different value on the screen and writing. So happens. And many times we have seen the system right in the wrong case sheet also. Since I worked in ICU, I've seen all this. Systematic error associated with the equipment. Consistently high or consistently low. Calibration. Twisted dial, zero error. Faulty delivery or measurement of parameters. Mechanical, electronic, pneumatic faults and errors related to the maintenance. Periodic testing, OVP is very important. Operation verification procedure is to be done as per planned protocol. Preventive maintenance program need to be executed judiciously as per the user's my service manual. If the service manual is not available, we are going to see medical device quality assurance program. It is going to tell at what frequency each and every medical equipment has to be tested for its quality performance. Biomedical engineering, error of planning, having a wrong protocol for maintenance. Negligence is, on the other hand, is a neglect, carelessness, inattention, abandon, disregard, slackness, casualness, forgetfulness, overconfidence, sometimes by the doctors, and arrogance. All these are in the industry. We have to face it. Failure to meet the standard of practice, failure to accept the protocol. When the degree of error is exceeding multiple times, it becomes a negligence. Every 6 months, a machine is to be tested. If it is not tested, it is an error. Even the second session comes even after 1 year. If you are checking the performance of the machine, it is negligence. People during disaster, what we are going through, COVID is a disaster. So the people are understaffed. When they are understaffed, you cannot expect them to follow the protocol. There is an emergency, around 20 people met with an accident, they are brought into the ICU. You cannot follow the protocol. And to follow the protocol, it has to be given adequate training. A protocol breach is also a negligence. So what is the key element here? Training is the key element, and it should be done constantly for both the patient safety as well as the device safety. What are all the medical errors here? Error due to medication, surgical error, diagnostic error, equipment error, infection, blood transfusion, order misinterpretation. These are all the classification of medical errors. Check the equipment failure. A diagnostic equipment or a lab equipment is failed. And when this lab equipment failed, what happens? It gives a wrong reading, and that gives a wrong diagnosis to the patient of the patient. And as a result, there is a wrong medication. You see? So see, equipment failure, where all it leads. This is as far as the diagnostic equipments are concerned. All lab, I'll give you a small example. 5 ml of your blood is sent to 5 different labs to check a bilirubin of yours. And I don't think all the 5 labs will give the same results. If they give us same results within the tolerance, it is accepted. But all the 5 labs will give almost the same results if all the 5 labs are, that the lab equipments are tested and calibrated for its accuracy. I understand you will believe this. Product life cycle of a medical equipment. What is the lifespan of a medical device? The medical device lifespan is just 6 to 8 years. 6 years for ventilators, 8 years for theater equipments like a OT table and the lamps, and not more than that. So can a machine work after that? Yes, the machine can work, but it will be economically not viable to maintain. The ventilator platforms are being changed once in 2 years. After 6 years, you are having an equipment which has got an old platform where the spares and accessories are very expensive. So it is advisable to discontinue the machine after 6, so that it's a very simple. You buy a car, for the first 3 years, it will not give you any problem at all. After 3 years, the frequency of failure will increase because of aging of the equipment and running of the machine, wear and tear. You change one component, the other component will fail the next month. So you do not know. So people are not using a vehicle after 5 years. Why should we use a medical equipment after 6 years? So better, the lifespan is 6 years. So the machines, the life-saving machines, the medical devices are manufactured, and most of them manufactured, the people are there, the design engineer, the product engineer, most of them are biomedical engineers. So it comes to installation and commission. The biomedical engineer does this. A trained biomedical engineer does the installation, and he does the commission, and he checks the performance of the machine, and he gives the quality assurance before putting it on a patient. Training and skill development. The biomedical engineers are the one who train the doctors, biomedical engineers, the nursing staff, and the technicians. They tell them how to use the performance, what all they should not do and what all they should do. They tell everything, done by the biomedical engineers. Maintenance repair. When the machine fails or preventive maintenance comes, the biomedical engineers execute them, the trained biomedical engineers. Periodic operation and safety standards. This is where the quality measurement and quality assurance comes. The testing and calibration of the equipment, the performance of testing and calibration to check how good these machines are when they are used on patient, how safe they are. Once the lifespan is over, you have to decommission the equipment and dispose them properly. Decommission is either like our burial or cremation. If they are radioactive material, it should be done properly. Batteries has to be disposed properly so that it gives a very less damage to the environment. That's very important. So after 6 years or 8 years, if you do not know how to decommission the equipment, call the manufacturer, they'll come and take it. Probably you have to pay the transport charges. Understanding the accuracy and precision, are they same? They are not. We are going to see what is accuracy and we are going to see what is a precision. Different measured value gives the same measurement, which is the true value of the patient. If the patient BP is 120/80, that means all the 4 measurements will be close to 120/80, which is the true value. So multiple readings showing the same value close to the true value of the patient, It's a high accurate and high precision. Degree of agreement between the recorded value and the true value are very close, may not be the same within the tolerance. Equipment that are recently tested and calibrated will show similar results, and the accuracy and precision will be very high. Thereby, the treatment to the patient will be very good. The outcome of the patient will also be equally good. So some examples I have given: high accuracy, low accuracy, high precision, multiple readings showing the same value, but those are all not the true value of the patient. The bullseye is in the center, which is the true value. But equipment showing the same value multiple times, we cannot construe that it is the accurate. It is precise, but it is not accurate. The degree of agreement between the repeated measurement is the same, but not close to the value. Repeated results means precision, but the accuracy is little away from the precision. Checking this machine, calibrating this machine will bring all the value close to the true value. So this is where the testing and calibration is important. High precision, low accuracy. And look at that. 4 different measurements, 4 different values, multiple reading different values. This equipment either requires calibration removed immediately without putting it on rotation. Let's see some paperclip assessments on medical errors and negligence. This was a case last year. Power kills 5 patients at Madurai Hospital, Rajaji Hospital, Madurai. Situation here is patients were on a ventilator, cause of death, power failure. Not able to digest this, not acceptable. This is not at all acceptable. Ventilator is a life-saving medical equipment. It is a life support. A life support, as I said, that's the function of the lung. So this machine is a high-end machine. All ventilators are supposed to have 2 hours minimum battery backup during failure, power failure, 2 hours minimum. There are machines which can run 10 to 12 hours on internal battery during power failure. There are multiple transport ventilators, they can work up to 20 hours. But an intensive care ventilator, which is inside the ICU, supposed to have an internal battery backup for 2 hours. A patient on a ventilator, power failed patient died, that to 5 patients at a time, not digestible. These internal batteries are to be replaced every 24 months as per preventive maintenance program. This is where the preventive maintenance program has come. So that means these ventilators, there was no preventive maintenance program, thereby the internal batteries are not changed. Madam, internal battery may have 3 years or 5 years warranty, but when you are using it on a life support, you are supposed to judiciously change 24 months, every 24 months. Use that battery for some monitoring purpose, not for the ventilators. So these machines, the batteries were not replaced. That means preventive maintenance program is not done for many years. The ventilator also has to be tested for battery operation at least once in a month. That's our Indian condition. In Bangalore, I've got 4 hours power failure, morning 2 hours, evening 2 hours. These are all scheduled cuts. Unscheduled cuts, you do not know for whole day, it may not be there. So in Indian scenario, all equipment have to be tested for internal battery operation. This is our condition. This is not stressed much in abroad because they do not have power failure. So this is the error by the biomedical engineer. It is an error by the management if they do not have a biomedical engineer. It is a negligence, not an error. It is a negligence by the management if they do not have qualified, trained biomedical engineer. If there was a biomedical engineer, it is his fault that he has not carried out preventive maintenance program. If a preventive maintenance was carried out, you see those, at least the battery would have been changed once in 24 months. These 5 patients would not have died. The previous week of this incident, there were 7 patients who died and the hospital did not take any precautions. Okay, they still started using the machine. Another case study. This case study is a beginner tragedy. Power cut kills patient in the ICU. Just a second. I do not know how to remove my. So cause of death is power failure. Internal battery backup failed. One more thing. Internal battery backup is a primary battery backup. There is a secondary battery backup, which is a high charged capacitor or whatever it is that will alarm when there is an internal battery backup is failed. So that's a second line of defense. Even that was not working. And preventive maintenance program not done. Ventilator inoperative condition is not noticed by the staff and the doctor. There's negligence on their part. If there was a total failure, the UPS and the generator supposed to have a backup. It's an ICU. ICU should supposed to have a UPS backup. If that was not done, then again it is the management negligence. Look at this. Another Madras GH. See, these are all very few cases which comes to light. There are many cases does not come to light at all. The people are died. The patient's relatives are told the patient underwent a cardiac arrest or respiratory failure. You and I cannot question. But the patient relative is a doctor. He will dig out everything and it becomes a medical case, medical legal case. So this person, who's a 42 years man, died because the ventilator failed. Cause of death is power failure. The patient was not disconnected immediately for manual ventilation. There are ambu bags available. So that was not done. At least they should do a manual ambulance. They've got standby ventilators. You do a manual ambu bag, wait for an alternate machine and connect the patient onto an alternate standby machine. This patient would have survived. Equipment was not checked for his performance. Error leading to negligence. Another case. 10 patients were on a ventilator. 9 patients survived, 1 patient died. So it is a 90% success rate, 10% failure rate. For this lady, he was the only breadwinner. Her loss is 100%. Okay, so you see no technical glitch, the engineer says. And he is saying what in the red line about total of 104 ventilators. They have got 104 ventilators. And all of them are less than 10 years. Life of a ventilator is 6 years. So how can they use a ventilator for 10 years? End of the 5th year, he is supposed to float a tender and buy the equipment to replace the old one with the new one. That is not done. 10 years is the life of. There are 3 engineers. How can they have a 3 engineers? According to the Ministry of Health and Family Welfare, every 100-bedded hospital is supposed to have 6 engineers, biomedical engineers, 6 engineers for every 100-bedded. If the 100 multiplies, you have to increase the number of engineers. 81 made in India ventilators failed the test at City Hospital. This is last week, just got few days before. This is for the COVID. 100% oxygen is not delivered anyway. So the quality management, the test protocol, they would not have followed. All equipment manufactured supposed to run continuously for 4 hours, 4 days, 4 days. And the data are acquired in a computer and the acquired data will tell how accurate is the machine. Probably that was not followed here. Electrical safety, fire accident. Fire accident, they do not know it is accident because of a short circuit. A short circuit means what? A wrong design maybe, a wrong wire selection, poor quality of wire, improper ground may also be another reasons. Absence of circuit breaker, it could be anything. It's not the fire accident, it is the electrical safety issue over here. ESU patient, plate burn, a small baby. The plate of the patient plate is not kept properly. The surface area has become less. Patient is the cathode and the cautery machine is the anode. The current was passing through the patient for the purpose of cutting, coagulating, and fulgurating. And when the surface area is reduced, concentration of current is more, the baby is burned. It could not cry because it was under anesthesia. Electrical safety failure, poor quality standard, babies, hospital, accidents due to negligence. I got around hundreds of clips like this. Every time I see, I only get frustrated. The nitrous and the oxygen got mixed up. And because of oxygen, the nitrous oxide was going to the patient. Look at this. This has happened in Bangalore. This lady, this girl is a small girl, came for a shoulder surgery. The brain did not get enough oxygen for 30 minutes. And people were keeping idle without knowing the baby was not getting oxygen. The quality standard of the anesthesia gas machine was poor. It was not even having an oxygen analyzer, which is to me, oxygen analyzer is a life-saving medical equipment. They keep a particular amount of nitrous and carbon oxygen, and according to the proportion, they calculate the percentage. The calculation would not have gone wrong, but because of the malfunction of the machine, the patient slipped into coma. She is still alive. Equipment was not tested for its quality assurance at a frequent intervals. All anesthesia gas, the machines ought to be tested for its accuracy once in 6 months. It is mandatory. This is the same case, and expert says there is nothing like overdose of anesthesia. There is no overdose of anesthesia anytime. If the doctor does overdose of anesthesia, they know how to reverse it. It is mainly underdose of oxygen. Oxygen percentage to the patient was less. The brain did not get adequate oxygen. This baby slipped into coma because of this. It is a total negligence by the anesthetist who administered anesthesia to this baby. On the other hand, it is also the responsibility of the biomedical engineer, if there was one, if he has not tested the equipment for its performance and not calibrated the equipment for its accuracy. Another case, 1-year-old baby, 3-year-old baby, died due to anesthesia, came for a dental procedure. So what is to the doctor? He is suspended for 1 year. He'll go and work somewhere. But the baby, for the parents, the baby is gone. Medical negligence, substandard equipment, lack of monitoring of oxygen, periodic maintenance would not have been done, equipment not performing according to manufacturer's standard, equipment not tested for and calibrated, anti-hypoxic gauze did not work. Anti-hypoxic gauze is a device inside the anesthesia gas machine that will see at any point of time the percentage of oxygen delivered to the patient is not less than 25%. So probably that did not work. It is the nitrous oxide and the oxygen, they are interconnected either through a belt or a chain. Probably that was broken, but whatever it is, the percentage of oxygen delivered to the patient is not measured. Gross negligence by the anesthetist. Another boy, 16 years boy, went for a minor surgery, died on the table. A woman dies of alleged anesthesia. So like this, we'll see what is happening over here. I'm going to take only one case study. We can't see all equipment. Anesthesia gas machine, there are three categories are there. Workstation you see on top. The monitoring is more than the delivery unit. The mid-segment equipment, you see, there is no monitoring at all, but there is only a delivery unit. One second. Sorry. The mid-segment has got no monitoring at all. It's only a delivery unit. That means what? The doctor does the calculation and he takes it for granted the set oxygen percentage is going to the patient, which is not true, which may not be true. Whereas the workstation, the percentage of oxygen delivered to the patient is measured. What the patient is exhaled is also measured. The percentage of nitrous going into the patient, coming out of the patient are monitored. Not only that, the percentage of anesthetic agent is also measured. They also have a patient monitor and a pulse oximeter, everything. That is why it is called workstation. So these machines, the chances of failure are very less, and the monitoring is fantastic. Mid segment, they do not have. Low end, just forget about the accuracy. So one case study, like where exactly the problem would have occurred. You see, there are two flow meters. One is the nitrous oxide, the other one is the oxygen. Both are giving 5 liters, 5 liters. The red bobbin tells you the doctor is seeing 5 liters over there. So totally 10 liters going to the patient. If 10 liters is 100%, 5 liters oxygen is 50%. Simple calculation. The doctor, they take it for granted, seeing the bobbin that the 5 liters is going to the patient. But you see the collar on top, the collar, there is a leak on the collar. The leak is giving out maybe around 3 liters oxygen, but the visual showing is 5 liters. So there is an hypoxia condition over here. The leak above the collar is a very dangerous, life-threatening situation. Saturation comes down immediately. Patients slip into coma, and sometimes most of them they die on the table. So this low-end machine should have, where the GFA is written, that's a gas flow analyzer, checking the performance of anesthesia machine. They should use at least an oxygen analyzer to check the performance. Had they used an oxygen analyzer, those paper clips which we have seen, those patients would not have died at all. 99% death on the table is mainly due to cautery machine and mostly due to anesthesia gas machines. Just a second. Okay. So the importance of testing and calibration, now you would understand. Any equipment or a device which has got a measuring. Measuring is a diagnostic equipment. Like your patient monitor is a diagnostic. Oxygen analyzer, SpO2 is a diagnostic product. Metering function or therapy equipments. Delivering a shock from the defibrillator. Delivering a volume from the ventilator. So any equipment which has got the measuring and metering function, they are supposed to be tested for its performance, for its accuracy at regular intervals. I'm giving an example. Blood gas analyzer. It checks the partial pressure of oxygen in the blood and partial pressure of CO2 and the pH. It should be very accurate. If the accuracy is not there, probably the patient will be intubated and ventilated. Defibrillator delivers a shock. I am setting 100 joules for a cardiac arrest patient. 100, when I set, 100 has to be delivered. If 50 is delivered, the patient is not going to tell, I'm sorry, I got only 50. You will not, even the person who's delivering the shock will not know. Defibrillators are not used on regular basis, but when they use, it has to work. First shock failed. I am giving a second shock of 200 joules. 200 joules set has to be delivered. Otherwise, the patient will kick the bucket. Cautery machine, electrosurgical, it passes some current through the patient. So the wattage and the current measured ought to be very accurate and precise. Critical drug infusion should be of high accuracy. Anesthesia gas machines. It is used for anesthesia delivery, and that has to work properly. So any wrong recording, wrong reading, wrong monitoring may lead to a wrong interpretation. The wrong interpretation leads to wrong treatment. That will lead to the wrong therapy, and that may lead to damage to the patient, increases hospital stay, and sometimes death to the patient. So hence regular check through testing and calibration of the equipment. It will ensure the uniformity, accuracy in diagnosis that leads to quality treatment to the patient. So what is calibration now? The calibration is a process of measuring or determining the accuracy with a known standard, which is nothing but the test equipment. So you have a test equipment, you can check the quality of the equipment. If it is a monitoring equipment, you've got simulators. And if it is a therapy equipment, you've got analyzers. We are going to see this soon. Minor adjustments without opening the machine, without moving the machine, is part of the calibration. Okay, so not the major readjustment. Open Madam, can you see this?
Yes, sir.
Okay. Shall we continue?
Sir, full slide is not there.
What do you mean? What do you see on my screen?
There are many icons which shows many windows.
Okay. Just a second. This
Okay.
one, correct?
Yes, sir.
Is it okay now?
Like, can you double click on it, sir?
Okay.
After choosing that, you like choose share screen once again.
Yeah, okay. Just a second.
Okay, sir.
Your scratch. Is this visible now?
Sir, not yet got selected, I think so.
Zoom, I've reconnected actually.
Okay, sir. No issues, sir. We'll wait for some time.
Okay, 1 second. Is it okay now?
It's a blank screen only, sir.
Okay, one second. I have shared the screen.
Yes, sir, but
So you're not able to see?
yes, sir. Yes, sir. Now it is visible, sir.
It's visible, okay.
It's visible, but press F5 to make it full screen, sir.
Yeah, okay, F5.
It's okay, sir. Now it's good.
Is it okay now?
Okay, sir. Excellent, sir. It's good.
Yeah, okay, fine. Okay, right. So the test equipments are classified as simulators and analyzers. Simulators, they simulate human signals of known value transmitted to the diagnostic monitoring equipment, and they see cross-check whether the simulated signals are shown on the equipment. The simulators also simulate mostly abnormal signal because that is what is to be checked with the diagnostic machine. Analyzers are meant for therapy machines. Like I told you, the defib, the set shock, 100 joules, whether delivered or not, with an analyzer, you deliver 100 joules into the analyzer will tell you it is 99 joules or 101 joules. So the analyzer analyzes the therapy equipment. The simulators simulates the human signal for the diagnostic equipment. Let's see. The human signals of various values are simulated and compared with the medical equipment. So what you see over here is a simulator, patient monitor simulator. What all it simulates? It simulates a non-invasive blood pressure, a pulse oximetry, various arrhythmias. That is what is important. ECG, IBP, invasive blood pressure, ECG of various values, and the cardiac output and respiration. So 8 parameters. That's why it is called ProSim 8. Okay, simulator 8. So this is one of the simulators by the Fluke. And you have got the pulse oximeter simulators. You see there is an electronic finger over there. The pulse oximeter probe is kept on the electronic finger, and it will generate the heart rate of various values as low as 30 to 240, and a perfusion from low perfusion to the high perfusion. And these simulated signals are to be reflected on the pulse oximeter. And there are various manufacturers. So one single equipment, you can check the function of all the equipment over there. Electrical safety. Electrical safety is a very important, it's an analyzer. This tells the quality of the power supply in the ICU or in a hospital, because the quality of the power supply is very important for the function of all the biomedical equipment. So the first and foremost is it checks the quality of the power supply from the wall outlets. Then it tells about the voltage, current, power, earth, leakage current, touch current, chassis current. The person using the machine also should not get a shock. So it tells, according to the manufacturer, whatever the manufacturer has recommended, this test equipment will check the voltage, current, power, and defibrillator is used to check the performance of the defibrillator, the set shock, whether it is delivered or not. What is the charge time? What is the discharge time? That is very important. When one shock is delivered, it cannot take another 5 minutes for the second shock. It should charge immediately. And they also check the pacemakers. So there are two kinds of defibrillators, biphasic and monophasic. So this one machine is sufficient to check the performance of all the defibrillators. Electrosurgery unit, otherwise also called cautery machines. And it checks the powers, it checks the current, frequency, crest factor, various load resistance according to the body. So this is a very important machine, and it has to work with high accuracy because there is some current passing through the patient. Incubator and radiant warmer. These are all measures inside the incubator, like what is the temperature inside the incubator, whether the airflow is there or not, what is the sound level inside, what is the humidity inside, what is the percentage of oxygen inside the humidity, inside the incubator, because it is a closed envelope. So you have to measure. So this test equipment is like a baby. You have to keep this test equipment inside the incubator, and you see there are around 5 temperature sensors are there, airflow sensors are there, humidity sensors are there. Close the machine and set the value on the incubator and check the value on the analyzer whether the set parameters are achieved or not. Gas flow analyzer, otherwise called ventilator tester. So this will check all the performance of all the ventilators, invasive, non-invasive, BiPAPs, CPAPs, O2 concentrators, air oxygen blenders, suction apparatus, insufflators, and all flows, volumes, and pressures. Anything related to flow, volume, pressure, you can check the positive and also the negative pressure. Okay. So this is VT650, the latest machines. We sold close to 200 analyzers in the past 3 months. There are so many companies in India have started manufacturing ventilator. We sold around 25 units only to Bell. Very important equipment. And this machine, with the help of this machine, we can see the performance of all the ventilators. Infusion device analyzer, drug infusion device analyzer. So there are so many equipments are there. I'm showing you only partial of the test equipment. There are loads of test equipment available in the flukebiomedical.com website. Since the time given is only 2 hours, so probably we have other programs to do. Medical device quality management program. So I thought if the time is not there, we will not take it, but the time is there, I think we can. There are another 25 slides are there. What is the purpose of this medical device quality assurance program? The objective is to determine the testing frequency of any biomedical equipment. A testing frequency of NIBP is different from the testing frequency of a dialysis machine or a ventilator. So what should be, all machines are important, equally important, but the critical functions of each and every machine is varying. So we have to vary the testing frequency. So this presentation is going to tell you about it. Quality management program, a medical equipment quality assurance, is part of the medical equipment quality management program for a healthcare facility, executed by a qualified biomedical engineer. What is the complete QA program says? Asset management. What is an asset? All medical equipment inside the hospital is an asset, right? From small pulse oximeter or NIBP to up to the radiology equipment, MRI or whatever it is, everything is an asset. Each and every asset has got an asset number. The asset management is when the equipment is installed, what is the warranty of the machine, when the next preventive maintenance is going to be done on that asset, and how to control this asset. Equipments are used within the department. And a medical ICU may take 4 ventilators from surgical ICU, and surgical ICU may take 10 infusion pumps from the emergency. So they have to know which machine is moving where and where is the location of these machines. And these machines have to be tested and calibrated at regular according to this importance. Planning and phasing out and bringing in new equipment is part of the, it's the job of the biomedical engineer. 6 years is the life of the machine. On the end of the 6th year, he cannot close down the ICU by shutting down all the ventilators. On the 5th year, we should plan, tell the management, 6 machines, ventilators, I am phasing out next year. So be prepared, buy new machines. Preventive and corrective measures, maintenance, need to be done according to the individual. Some machines every 5,000, some machines every 10,000 hours, some machines once in 6 months. So he has to know in his software, 1 month before, the software will pop up and tell preventive maintenance is pending for all these machines which are falling under next month. Education and training is part of the biomedical engineering. You should educate and train the ICU staff how to use the equipment for performance and maintenance, and otherwise life will become difficult. You cannot tell a sister anything unbreakable before you complete your word. She will break that into 4 and give it in your hand. So you have to tell how to handle the probes and where to put catch the collar and pull out the probe and not by the wire. This education is important so that the failure of the components will be less. All activities directed towards improving the medical device, which is directed towards the patient safety. Patient safety is the first. Objective of QA is to preserve medical device quality and related patient safety. This is part of the QA program. Equipments are classified as diagnostic, therapeutic, OT equipment, lab equipment, and imaging. So Helix is concerned with the diagnostic, therapeutic, and OT. And we have got the test equipment for all these machines. Lab equipments are different. And imaging, it is a radiology. It requires a high skill and knowledge. What is the purpose of the medical equipment quality management program? First of all, the equipment should be safe. It should be safe for the patient. It should be safe for the user. It should not transmit any electricity to the patient, and the doctor who is touching the machine also should not get any shock. This is the safety. Accuracy. Performance of the machine should be accurate. It should be accurate and precise so that it is ready for patient use. Without safety, without accuracy, no equipment should be used on a patient. So risk assessment and risk management. What should be the frequency of testing and calibrating is based on risk scoring. We are going to see what is a risk score. Clinical function. Clinical function is the first criteria. Physical risk is the second criteria. Clinical function means how invasive is the medical equipment to the patient. It is touching the patient or it is not touching the patient. Some catheter goes into the patient, through the patient, or it is not. Whether the patient is intubated on ventilator. So how invasive? That is the one. If you see the weightage of this, there are medical devices that do not touch the patient. If you see the OT lights, it do not touch the patient and the function is non-critical. Radiology product, again, not touching the patient, but the function is critical. What else? Radiant warmer is not touching the patient, function is critical. And the phototherapy lamp is not touching the patient, the function is non-critical. So how invasive is the machine? You have to know, you have to give a score on this machine. So if you take a pulse oximeter, if you see down with the equipment, weightage and risk scoring, device is used for patient diagnosis or direct monitoring. What it is? A patient monitor, a pulse oximeter. A device is used to deliver direct treatment to the patient. What it is? It is a defibrillator. Device is used for life support. That is, the risk score is 5. That means a ventilator, a dialysis machine, a heart-lung machine, intra-aortic balloon pump supports the heart. So these are all the life support machines. So if you are taking any one of these machines, you have to give a score of 5. Physical risk. What will be the outcome if the equipment fails? Nothing happens or something happens, or patient stay in the hospital is delayed for a few more days, patient is crippled for life, or immediate death. These are all the scorings of that, which we are going to see in the next slide. Problems, avoidance, probability. What is the chance of failure of the equipment if a preventive maintenance was done? Nothing or avoidable failure. Incident history. Was there any incident before in the hospital that the machine failed and the patient died? Yes or no? Manufacturer's recommendation. What is the maintenance schedule? Whether they say or not. If they say every 5,000, 10,000, 20,000, whatever it is, there is a scoring for that. And we are going to see this risk scoring. Okay. Risk-based inspection and testing interval. Testing frequency is based on risk criteria. What is the risk criteria? Weightage is given for each criteria with the risk score before. Total risk score is going to determine the testing frequency. Very simple, very simple. Clinical function, what is the risk score you are giving? Take, for example, a ventilator. Clinical function is 5. Risk, physical risk is also 5 because the machine fails, the death is immediate. That is what we have seen in the paper clips. Problems, avoidance, probability. Have they done a preventive would have taken over the patient automatically without missing it, the patient would have survived. Incident history. Was there any incident before that the ventilator failed and the patient died? Yes. Regular manufacturer, do they say that the machine is to be checked for its performance? Yes. OVP is a procedure in the operation manual that is going to tell at what frequency the machines are to be tested. So the plus gives you a total risk score. If the risk score is more than 13, those machines have to be checked for its performance once in 6 months, semi-annual, once in 6 months, not twice in a year. If the score is 9 to 12, once in a year. If the score is less than 9 or 8 or less, biannual. Those medical equipment are to be tested once in 2 years. Let's say clinical function, how invasive is the equipment? Take any particular equipment like a ECG, NIBP, or a ventilator, or a IABP, whatever it is. Take one machine at a time and see what the machine does, how invasive, whether it is touching the patient or it is not touching the patient. If it is touching the patient, whether the function is critical or non-critical. So if you see the thing, device is used for patient diagnosis or direct monitoring, that is a ECG and a pulse oximeter and what else? So these two machines are patient monitors. The scoring is 3. The risk score is 3. How invasive is the machine? A ventilator, the life support, it is 5. The scoring is 5 for the ventilator, IABP, dialysis machine, and heart lung machine or whatever it is. So we have to take one machine at a time, give a score. So the scoring is based, no patient. The score is 5. Physical risk, how severe is the outcome if the device fails? Inconvenience to the patient or immediate death to the patient. In between is the injury. People are crippled for life by wrong surgery and by wrong anesthesia. And some people, they have to overstay in the hospital because of the wrong treatment or whatever it is. So the outcome fails. If the device fails, what should be the risk? 1 to 4. So if it is a ventilator, I will give the score as 4 because immediate death. Common device failure, is it predictable? Can this be avoided by preventive maintenance program? A pulse oximeter, there is no impact for preventive maintenance because there is nothing inside the equipment. It is only the probe outside. Whereas the ventilator is a device that delivers some volumes, pressures, and oxygen percentage. So if you have done the batteries, if you have done a preventive maintenance, the failure is avoidable. So I give score 5 for ventilators and maybe score 2 or 3 for the pulse oximeter. Historic data. Have the machine failed and patient died? So no harm is 1. Yes, there is a harm, 2. The scoring is either 1 or 2. Does the manufacturer say the machine is to be checked at a particular frequency? Yes or no? If it is yes, 2. If it is no, it is 1. Now let us take, I think it is a pulse oximeter. The clinical function of a pulse oximeter. It is a device used for patient diagnosis or direct monitoring. The weightage is 3, so the risk score is 3. So if the SpO2 monitor fails, I think you are not going to lose the patient. You are going to lose only the monitoring site. I can use another machine in place of that. Physical risk. Device failure will result in inappropriate therapy, misdiagnosis, and loss of monitoring. So the physical risk involved is if the machine fails, I will not get any monitoring. So the scoring is 3. Problems avoidance probability. Have I done preventive maintenance? Can I avoid the equipment failure? Not in the pulse oximeter. So the risk is 2. Previous incident history. A pulse oximeter failed and a patient died. There was no history like that. So the score is 1. Does the manufacturer say that the machine is to be checked at a particular interval? It is not so. So the score is 1. So 3 plus 3 plus 2 plus 1 plus 1. The total score is 10. It is less than 13. and it is above 9. So it has to be checked once in a year. A pulse oximeter should be checked for its performance at least once in a year. So this is what we get from the MDQA program. The second is a ventilator. Let's take the ventilator. How invasive is the ventilator? The invasive ventilator, when the patient is intubated, paralyzed, and is sedated, is deeply paralyzed and fully sedated, and the tube is gone through his throat into the trachea, that means it is an invasive. And second, it is a life support. Life support does the function of a human organ here, which is a lung. So the score is 5. Device failure, incident history. Device, as the equipment failed and the patient has died, the failure of the machine will lead to immediate death of the patient within a minute or two. Okay, we cannot hold our breath for 2 minutes. Okay, so within a minute or 2 minutes, the patient is already on a respiratory failure. Failure of the device will further deteriorate him. Even if you revive, if the saturation has gone below a particular level, he will slip into coma. But most of the time, death. What is the likelihood of the failure if you have done a preventive maintenance program? If there was a preventive maintenance program, the failure is avoidable. Okay, that we have seen. So the score is 4 over here. Previous record, have the ventilator failed and patient died? Yes, so the score is 2. As the manufacturer say the machine is to be checked for its performance at a particular interval? Yes, the score is 2. So 5 plus 4 plus 4 plus 2 plus 2, it is totally 17. It is 13 and above. So ventilator has to be checked for its performance every 6 months. There are other risk score like an electrosurgical unit. The total score is 13. So the performance verification testing frequency is semi-annual. Ventilator, we have seen semi-annual. Pulse oximeter 10, so once in a year. Operation table, it's nothing going to happen in an operation table over there. But why it should be checked for once in 2 years? Because the operation tables also have got electrical sockets in it. If there are electrical sockets, then it has to be checked for leakage current. The patient will not tell if he is getting shock. The surgeons are using slippers for doing the surgery, so nobody will tell. And patient is in deep anesthesia. He also will not tell that he is getting shock. So you want to see whether the patient is getting shock or not. Come out of your slippers. Now touch the patient. You will know whether there is a current passing through the patient. Labeling is very important. All medical equipments are labeled at the back. You see half-yearly maintenance, annual maintenance, quarterly maintenance. Everything is a color code. So biannual is blue, annual is yellow. Semi-annual, very important. It should be checked once in 6 months. These labels are going at the back of all ventilators, apart from asset number. Very important. Performance done by whom? Who did the performance of checking this machine? What is the name of the engineer? And what is the date he has done? He is making somebody personally responsible for the equipment that has been tested. Electrical safety test, when it was done, what is the date? When is the next due date of the safety? Battery replaced, very important, because the batteries on a life support is to be changed once in 24 months. So you have to put the date of changing and the due date of the next due date when it is supposed to be changed. And this goes into the asset management. Okay. Non-hospital owned equipment. Equipments are these days rented. So an equipment coming into the hospital, it is first to be disinfected. It is supposed to be checked for its performance, electrical safety. Then only the biomedical engineer should send this machine into the ICU. These machines are to be disinfected because you do not know on which all patients these equipments are used. This equipment is under warranty, so do not touch it. You touch it, the warranty goes null and void. Defective, do not use. This sticker, every biomedical engineer has to carry in his pocket. When he goes to the ICU, when he checks the performance of the machine, he has to slap the sticker on the front of the ventilator or equipment. They cannot tell the sister, I am going down, sending somebody to move the equipment to the department. That will not happen. The sister will go that side for the tea. Some other person will come. You will use this machine on a defective machine on a patient. Defective machine, the sticker should be on the front of the ventilator or any equipment. So conclusion summary. So the role of a biomedical engineer, you all will understand, is as important as a doctor. But I disagree with my own statement over here, because the role of a biomedical engineer is more important than a doctor. Unless he certifies the machine which is safe and accurate for patient use, the doctor cannot use this machine. And sometimes in some places, the doctors, they bully. And but you have to put your foot down, saying that the machine is not under use and not under performance, so it cannot be used. You have to put your foot down. So hence a biomedical engineer should thoroughly understand all the equipment under their care. They have to know the application of the machine. They have to know the principles of operation, all the parameters, primary and secondary. A biomedical engineer, if he doesn't know the application and the principles of operation of an equipment, you will not have any confidence to touch the machine. So this is very important. Requirement of trained medical engineers are increasing day by day. There is a giant leap for the past couple of years. After the Ministry of Health has declared that bringing in a quality standard, the NABH hospital have to appoint minimum 6 engineers for every 100-bedded hospitals. The responsibilities of the BMEs are very high to maintain in perfect working condition as per manufacturing standard. This is very important. There are few engineers in most of the hospitals. They are overworking, I know that. And they are working hard. They are giving the care for all the life-saving medical equipment. There are secondary machines that also requires their concern. So very important. Any equipment that is not up to the quality standard should be removed immediately for service to prevent damage to the property and to the patient. Remove the machine immediately from the department. Take it to your department, leave it over there, and see what is the fault. No compromise on the quality standard at patient safety of the patient. The doctors, the nursing staff, the technicians, the biomedical engineers, you are all there for the patient safety first. Understand the machine, you read the manuals, and see that the machines which are under your control are working good. Training program is important to the doctors, nursing staffs, and the technicians on usage and maintenance of the equipment to avoid mishandling. Otherwise, your life becomes miserable. A BME to be well organized and disciplined in the following manner. First of all, the dress code, I have seen many of them. It should be neat and proper. The doctors, when they enter the ICU, they get respect. So the biomedical engineers, when they enter the ICU, they also should get respect for their knowledge and the dress code. Keeping the workplace clean and tidy. 90%, I have not seen there's any biomedical department. You open the department, there are cables and the tubes on the floor. You have to hip hop to go to the chief HOD of the biomedical. That should not be the case. All tools are to be well organized, properly placed for emergency call. This is very important. Every cupboard should have the tools related to one particular equipment. There may be replications. There may be 4 spanners. There may be 4 different test equipment. Have them separately. The reason, you are getting a call from the ICU that the ventilator is not working. You are getting, same time you are getting a call from the theater that the cautery is not working. And you are getting an emergency call from the emergency saying that defibrillator is not working. You are alone over there. Where will you run first? You should be educated on that. The ICU patient can wait because there is a doctor, he can take manually back the patient. The cautery can also wait. There are 4 or 5 doctors are there. Patient under the anesthesia, his respiration is taken care. But the defibrillator patient cannot wait. You delay, you will die. The golden time is gone. It's gone. So the people have to be educated properly, for which a call has to be attended first. And if he's got a particular tools, open the cupboard, take the test equipment or the toolkit, run to the emergency. So these has to be well organized. Just a second. So his library should be pakka. All the user manuals, maintenance manuals, you should have both digital or whatever it is. You should arrange it properly. So in emergency, you know what to take from where. Asset management in a scientific way. All equipment coming to the hospital need to be checked for its performance with the test equipment. Equipments are manufactured somewhere in some country. The quality, okay, they say when it is leaving the factory. After leaving the factory, it is being packed. It comes through various countries. It comes through various airports. It comes through various ground handling agencies. When it is reaching the hospital, the machine may not be okay. It was okay at the site of manufacturing. So what he has to do, he has to open and inspect the machine, check the performance of the machine before delivering it to any of the department. Physical fitness is very important. Mental alertness is very important. He should have his antennas strong, mental, physical, ear, eye, everything, so that no, he should be able to diagnose. Logbook he has to maintain, which I have not mentioned here. Whatever he does every day, he should write it on the logbook. Personal hygiene is very important. When you touch the machine for service, you do not know whether it is a H1N1 or a HIV or a COVID, you do not know. So when you are going out for a coffee tea, you have to sanitize yourself properly. So you have this is a ICUs and hospitals and the equipments are all source of infection. So you have to maintain your personal hygiene. Demonstrate an excellent caliber in the hospital, in the job you do. Thereby you command respect for your life in the workspace. So the sisters, when you give a demonstration to the sisters, when you train the doctors, when you train the people in the technicians, you will automatically will get respect. The first time they go, probably the doctor may ignore you. But when you throw your light, your knowledge on the equipment, the way you demonstrate, the way you train, you can see his face will change. Next time you go, you need not have to wait. He will come and attend to you immediately. So this is very important. Knowledge is power. That is for sure. Ignorance is darkness. That is also for sure. Even if your knowledge is less like a candle, at least you know what is the next step you can keep in the darkness. Role of the teaching institute and the university. The universities should come forward to develop the biomedical department. The focus for the student should be at least 50% to my knowledge. What they are reading and what the industry, they are entirely different. The students, when they come for the interview, when we interview them, and we see the fear in their face, absolutely no confidence. So what the institute should do, you provide an environment of the hospital inside the institute. Provide a mock ICU equipped with all ICU devices. Yes, some people, they say, no, we take them industrial visit. Industrial visit is of no use. You take an ICU, 4 to 5 students at a time, you are not allowed more than that. Can the student touch the equipment? They will tell from far, that is what is the ventilator, this is the infusion pump, don't make noise, slippers outside, get out soon. What is the confidence they are getting over here? So the teaching institutes should have an ICU-like environment. Use a refurbished machine, doesn't matter, but create from the bed. You have an ICU bed, you have an infusion pump, you have a ventilator, a patient monitor, and a suction apparatus, and a pulse oximeter. Create and maybe a patient mannequin on the bed, so the students who go inside can confidently touch any machine and check the performance of the machine, so that you get the confidence. You also should have a mock OT. A mock OT means an OT like the OT. So patients, how many biomedical engineers have gone into the OT, see what is a OT? What is the theater like? What is the lux of the theater like? What should be the lux of a neurology department, neurosurgery? Everything they should get an. And you can also have a lux meter to see what is the lux emitted by the theater light. So this is very important. The teaching institute is supposed to have all this. You also should have a CAL lab, a separate lab. The machine create a fault in the patient monitor, remove the cable, put a defective cable so that the students can take it to the CAL lab, check the performance of the patient monitor with the patient monitor simulator. Hands-on drill is very important. Hands-on drill will give the confidence. The confidence, once they are confident, when they go for any interview or whatever it is, they'll be able to face the people confidently. The table will be entirely different over there. Should associate with the medical industry. So the institute should associate, write an MOU, because the industry has got the latest knowledge. They know the current technology. What equipment is released in US is also we know over here. So you have to write and call them on monthly basis so that they share their knowledge. Most of the people, they do not hesitate to share their knowledge. Utilize the experienced retired manpower who are sitting at home and they're ready for a second round. Call them. They are ready to come and teach. This time the teaching will be unbiased because they are not representing any equipment. So they will tell very clearly the positives and negatives of all the equipment. So what is the role of the biomedical department in teaching institute? You have to put your foot down. Pressurize the institute to go for the above. Tell them at least buy one equipment or two equipment at a time. At least in the course of 2-3 years, you would have developed your own department, your own mock ICU or a mock OT or whatever it is. There are refurbished equipments available. You can buy from them, which has got after sale support. A CAL lab and basic medical equipment are mandatory for the BME department. So Anna University has got a beautiful CAL lab. Nimans has got a beautiful CAL lab. There are so many institutes there from Chennai. We have given a proposal for a CAL lab. Not necessarily you have to buy our equipment. Buy a second-hand machine. It's okay. It's only for testing and calibrating to know the knowledge. A second-hand machine also will do. Allow the student to touch and feel the machine to understand and get confidence on using the machine. So periodic knowledge sharing program, you have to do it utilizing this industry. This is the first time I'm interacting with you. I know Karunya for so many years, but it's because of Madam Mani Megalai, things have come, or Amos, John Amos. You are in touch with me now. Now you understand what the industry has got to offer your teaching institutes. Okay, this is the same. Okay, pressurize the institute that work, conduct periodic, add to the students' curriculum, testing and calibration of the medical equipment. Why this is not there in the curriculum? So when you become deemed university or whatever it is, there should be one unit of testing and calibration of medical equipment that should be there in the students' curriculum. You have a tie-up with Nimans. Nimans has got one of the best, Asia's best CAL lab. I know the lady who's standing next to me on my right side is Sindhu, HOD department. And very nice lady. She encourages students internship. On my left is Jarina, ex NGP student, and she's going to head the lab. So I know all of them. So you want, I can put them to you across, and you have to send at least 20 to 20 students at a time. And she will give the test equipment, and she also will give you the devices for checking purpose. Okay, so this is the Nimans CAL lab. Last year it was inaugurated. You see all equipments are there. All equipment, it is close to 1 crore worth of equipment inside. This is the lab which you are seeing over here. This is the day of inauguration. Okay, various agency involved in healthcare. QCI, Quality Council of India, that's the parent agency. Under them comes under Department of Science and Technology, Ministry of Science and Technology, Ministry of Health and Family Welfare also comes under that. And this is the hierarchy of the QCI. QCI is an independent agency and they make all the rules and regulations. Guidelines from MOH is Ministry of Health and Family Welfare. They said the 100-bedded hospital is supposed to have 6 engineers. If the beds are more, then the engineer has to be increased. This will come soon. Around more than 1,000 NABH hospitals are already registered. And there are, to my knowledge, there are around 3,000 hospitals in queue to get NABH accreditation. So that means what? Close to 1 lakh biomedical engineers are needed in 3 years' time. Medical equipment device maintenance manual is there available in the Ministry of Health and Family Welfare. Every biomedical engineer should have this. So this is the link over there. When you click the link, you get the manual. Can you see, madam, this manual?
Yes, sir.
Yes, sir.
Yeah, okay. You look at this. It is designed by one of my friend who is SB Sinha. He's in this line for more than 40 years, and he's got a team. He's assisting Ministry of Health and Family Welfare. You see, these are all the content. You can download this and keep a copy. You see everything, the purpose of this manual, the format of this manual, acknowledgement, who was management involvement. Look at this chain link. So if you go down, types of medical equipment maintenance, this is devised by him. Okay, this is a group of engineers. They are a group of engineers. So you can know everything like anesthesia gas machine. They say, what is the anesthesia gas machine? What is the function? Download this manual. Okay, where is my presentation now? Okay. So
Yes, sir.
Fluke Advantage Training Program. You see the flukebiomedical.com is the website. Go to the website, go to the knowledge center. In the knowledge center, you see the advantage training, you click that. So when you click that, it will ask, this is the page you will get advantage training. You click the advantage training, get training now, the circle over there, register with your name and password. When you register with your name and password, it will take 2-3 days now. And you will get these study material, loads and loads of course material, which are not available in any textbook. Okay, so you see the electrosurgery.
Ma'am.
Yes, sir. Let us wait for a minute. He may come back.
Okay.
He'll be trying.
Dear all the participants, feedback form is already in the chat box. Kindly fill it up. If you have any questions, kindly post in the chat box.
Can you get the details of the speaker, sir? Contact details, the mail ID.
Sure, sir. Sure, sir.
Right, post please.
Manimela ma'am, do you have?
Samson, sir, you talk about the afternoon session that starts at 2:30.
Okay, sir. Good afternoon, all. Afternoon session will start at 2:30 p.m. So kindly join us at 2:30 p.m. Dr. Kadiresh from PSG College of Technology will be sharing the session.
Samson sir, sir is trying to reconnect. Let us wait for a minute.
Okay, ma'am.
Madam reconnected. Okay.
Thank you, sir. Thank you.
பாருங்க தெரியுதா?
Like screen is not visible, sir.
Okay. Just a second.
Okay, sir.
Just a second.
Hello.
Sharing.
Hello.
Yeah, sir, you have
Hello.
started sharing. Yes, sir.
Hello. Can I ask a question, ma'am?
Not yet, sir. Let me finish this. Then you can ask any question. Okay. Madam, the screen is visible?
Yes,
Sir.
It is visible, sir.
Yeah, okay. Another few more slides, and then we will go to the question answer session.
Yes, sir.
Yeah, okay. Okay, so this is the certificate you get. And you see these military people, they are the biomedical engineers in the army. They are the one who handle biomedical equipment in the war front and in the all army hospital. The person in yellow shirt is Nanda Kumar. He is the CEO. I am only the general manager. Okay. And we conduct many programs. This is last year Mahindra. We also conduct workshops and intensive workshops, one-day crash course, industrial visit, students from PSG. We took them to Fluke. And this is the PSG. And so students are checking the accuracy of a ventilator with the gas flow analyzer. This is a value-added course. Check the face, how concentrated they are. We also do ventilator work for the hospital biomedical engineers. It will be a military drill. And we also conduct programs to the doctors. This is Colombo, Sri Lanka. We went to Ragama Hospital. And this is module 3, high-level training. This is to the doctors of Care Hospital, Mysore, a fine-tuning of ventilator parameters. My friend, Dr. Manjunath, professor and biomedical engineer, how they are. Now the biomedical engineer is getting a place in the gate. Okay, so now you know the importance of biomedical engineering. Now the questions. Sir, please ask the questions.
Hello.
Yes.
You are getting me, sir, clearly?
Yes, I'm able to hear clearly. Tell me.
Namaste. This is Ashok Kauchar from Maharashtra.
Yeah, welcome, sir. Tell me, sir.
As the subject today's was organized very well and important one to this medical biomedical subject, as all the world and every people are thinking of the same with pandemic situation of this. Yes. At every instance.
Thank you.
I have an important question that if we have an instrument or a box which has the facility of that coronavirus is killing.
Yes.
Yeah, if we keep our pocket, wallet, or the key of the vehicle inside it for some time, and how to ensure that the viruses are killed or not?
Okay, beautiful question.
Ultraviolet tube is fitted in that box.
Sir, very good question. Honestly, I don't know the answer. We are taking
no
precautions.
problem.
Everything is everybody, different people giving different opinion. And all that I know is I wash my hands. I have serviced the corona ventilators. Last month, I went to Bijapur District Hospital. There were 3 ventilators in corona ICU, corona COVID ICU. And I checked the performance and with the 2 gloves on me. And
Mhm.
but the very next day, I fell sick for 14 days. I was bedridden with viral flu, not COVID. Okay. So
Oh,
I really do not know whether I got COVID or not, because all COVID I got only
acha.
symptomatic treatment. But
Mhm.
it took 14 days for me to recover. Even now, I am not fully recovered. So I am
Mhm.
not able to give you a proper answer to your question. You
Mhm.
have to talk to some virologist. Probably they'll give you a better answer.
Rather, my intention is that how the instrument or the box is made for killing the viruses with ultraviolet rays. How to ensure that or how to calibrate that? That is my question. Is there any facility? Or if you are unable, please give me some other source so that I will contact in your friend or group or in this line who can, if possible.
This query can be solved by a biotechnologist or some food processing engineers, because they might be expertise in it.
Okay. Thank you, ma'am. Okay, no problem, ma'am.
Okay.
Thank you. Thank you, faculty also.
Professor Vijendra Babu.
Hello, sir.
If you have a question, please ask.
No, sir. That's,
Post it.
I got his contact number. That's fine, sir. If you're able
Fine,
to get the
thank you.
contact number, it will be fine. I received a mail.
Okay, sir. We will post it in the chat. I mean, WhatsApp group.
Okay, sir. Thank you.
Thank you, sir.
Samson sir, we'll wait for a minute. We'll officially thank and close the session.
Yeah. Okay, ma'am. Participants can please post the questions in the chat box. Professor Maithili ma'am has asked a question. Can you give a chance to visit the company for our biomedical students? Ma'am, I have given the email link of the resource person. I think you can contact. Maithili ma'am.
Participants, you can kindly hold on for 2 more minutes. Let us officially thank him. Sir? JP sir?
Can you hear me?
Yes, sir. Yes, sir.
Yeah. Sorry, there was some net interruption. It is
No
fine.
issues, sir. No issues, sir. Sir,
Yeah,
one
madam,
one
any
madam.
questions?
Sir, one of the participant had asked a question, like to give a chance to visit your company for biomedical students.
Uh,
we,
see,
we gave your official mail ID. They'll make.
See, madam, this Helix is a very small company. We are around only 20 people. But I can arrange their visit with Nimans. Okay, Nimans I can do it.
Okay,
We
sir.
tied up with Vasavi Hospital, but Nimans is better because they can accommodate 200 people at a time.
Okay, sir. We'll also come.
Helix
We'll
is
also come.
we
We'll
are
also come, sir.
very small people, madam. Yeah.
Okay, sir. Sure. No more questions, I hope so, sir. I'll. So thank you, sir. Thank you for accepting our invitation and being with us today, spending a precious time. Really, it was an interesting and informative session. Like we were impressed by the presentation in both the ways, the slides as well as the presentation style. Like it proved your expertise, sir. I hope participants would have got a clear idea on patient device and safety and awareness on the importance of testing and calibration. Thank you. Thank you, sir. Thank you, sir.
And how many people attended, madam?
Sir, around 50, sir.
Oh, very good.
We don't know the count, like who and all have attended, I mean, through YouTube. In the
Oh,
Zoom.
through YouTube also it was done, huh?
Yes, sir. We'll share you.
Please share, madam, because my knowledge is very less on all this. I would like to share my knowledge with people so that the people get benefited, the society, everybody should get benefited out of it.
Sure, sir. We'll send you the link shortly.
Thank you for the opportunity given, and hope everybody enjoyed this program and got some knowledge out of it. And you can give my name and email ID. Whatever possible from my side, I will do it.
Yes, sir. Thank you, sir. Thank you so much.
Thank you. Welcome.
Okay, sir.
Yeah, bye-bye.
Okay, sir.
Madam, சொல்லுங்க. Sorry, I went to the washroom. Oh, wait. Sure. Thank you. Oh, thank you. Oh, sure. Thanks, madam. Thank you.